All right, everybody, we're picking up with the second half of our review guide in the video. And as we get ready for this one, all you're really focusing on is exponent tricks, exponent rules. So first thing I would do, if it were me, I would start by making the Mr. T's patent pending, famous exponent chart. What is Mr. T's exponent chart for? This is to help you figure out what you're doing with your exponents. So first things first, let's look up here, up top here. I've got a, and then I've got raised to the b plus 3 power. Well, what that means is I am raising a power to a power. We'll go over to your exponent chart. That's right here. When the base, you're raising a power to a power, that means the exponents are going to be multiplying. Why? Because little numbers are a little slow. So while you're doing one thing over here, little numbers are back doing the thing before it. All right, so this means x to the ab plus 3a. Okay, just distribute that a through. And for the same reason, y to the ab plus 4a. All over. And just leave the bottom alone, like clean up all the top as much as you can, clean up all the bottom as much as you can, and then do that next step, okay? So negative 2a, don't put that up to the top. Some people would say, hey, I got a negative exponent. Why don't I just move it to the top? Technically, you could, but you're just adding extra steps, and you don't actually need to do that. So here we go, y to the 3a. Now, next thing I'm doing, looks like I'm dividing with common base. See how the x is right here and x is here? They have the same base. I'm dividing. Guess what little numbers are doing? Little numbers are a little slow. They're subtracting. Come on, step it up, little numbers. That's all right. So this is going to be x to the, and just do ab plus 3a. But now you're going to subtract, because you're subtracting according to the chart. Subtracting what? 2a? No, 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 no. You're subtracting negative 2a. So protect it with parentheses if you like. Okay? And this would be y to the ab plus 4a. And same way, we're going to subtract 3a. Okay? Subtracting a positive 3a. Now we'll just clean this up just a little bit by osmoto. Remember, subtract means add the opposite. So this is x to the ab plus 5a. And that looks good. And then this would be y to the ab plus a. And that's about as far as you can go. Fun stuff. All right, and I think I did this one before, so I'm just going to talk you through it real quick. If you have a square root, okay, doesn't matter if it's a cube root, square root, fifth root, doesn't matter. The process is the same, but you can use this trick and you'll get them all right. So first thing I want to do is I want to break down 8. 8 breaks down to 4 and 2, and that's 2 is prime, and 2 and 2. So your fruit is 2 times 2 times 2. Now, you've got also h to the 11th power, which means you have 11 h's chilling in the bomb shelter. These guys are all in the bomb shelter, and I literally just wrote them all out, okay? Now, when I do that, I say, hey, when I get 2, they can come out as 1. So, and I have 2 h's, and it's a midterm, guys. Go ahead and write all the h's out. Make it fun. It'll make sure you're doing it the right way and all that stuff. And so pair up all your h's, and all of them pair up except for 1. Anytime you pair them up, they spit out 1. So anytime you pair them up, they both try to escape the bomb shelter. Tragically, 1 is horribly mangled and just, it's pretty tragic. Anyway, so you just get 1 out of there. And so all the h's outside here, I'm just going to count them up. 1, 2, 3, 4, 5 h's and a 2 are outside the bomb shelter. And what's left in the bomb shelter is just this 2 and this h. And that what goes under the bomb shelter. So that's what the answer looks like that. Okay, so this is a really nice technique because you're not going to make any mistakes if you just follow this process. And it's so colorful. All right, what's wrong with this one? Well, we're going to have to clean up. We don't want radicals in the denominator. So if it was like 4 plus rad 7, we'd try to multiply it by the conjugate. But because it's just 4 rad 7, all we need to do is throw another rad 7 down here. Okay, and rad 7 times rad 7, right? As long as you do it to the top and bottom, it's cool. So this would be 3 radical 7 over, and then this is going to be 4, the rad 7 times rad 7 just gives you 7. So 4 times 7 is 28. So 3 rad 7 over 28, that was a pretty quick one. All right, moving on. Value of sine, cosine, and tangent of angle A. So put your little man up here. Hey, there he is, he's chilling. All right, now according to this guy, this is the hypotenuse here. Okay, it's always crossing the box. And this is the opposite of him. So put O there. And adjacent means next to. So there's all your letters. You're good to go. So sine is opposite over hypotenuse. So sine of A, or angle A, you could say. Sine of angle A equals the opposite. So that's 15 over 20. Okay. Cosine next. Cosine of A equals, yep, it's cosine. So this is adjacent over hypotenuse, ka, remember? So ka, and then toa. Soka choa. All right. And this is going to be 20 over 25. And the last one is tangent, which is going to be opposite over adjacent. So that's tan of A equals 15 over 20. Okay, that's all you got to do. That was fun. All right, so fun, so fun. And you could reduce those fractions, obviously, but you get the idea. Technically, you could make it decimals too. Number 25, let's graph the domain and asymptote, and I apologize for these funny things. If they are on the midterm, which I may not be able to avoid, just ignore them. Okay, I think there's kind of stand-ins for like big brackets like that. So, you know. All right, so let's graph this one, identify the domain, the asymptote, and the range. All right, so typically you can automatically plot a point in there, the point being x equals 0 when x is 0. When x is 0, anything to the 0 power is always 1. So you know you're going to go through this thing right here. Now, 3 halves, that's 1 over, that's 1.5 or 1.5. And so 1.5, like if it was equal to 1 to the x power, it would be a flat line at 1. But anything above 1, it starts growing exponentially. So essentially, your curve's going to look like this. Okay, that's a really rough sketch in, but you get the idea. Your domain, any x's you can't plug in there? No, this is all real. Your asymptote. An asymptote, remember, is a line that, that your graph is approaching, but it never really touches it. So no matter how small this x is, if it's negative like a million, that's just a really small fraction, but it never gets to 0. And so this purple line is going to get closer and closer to that red line, but it's not going to touch it. So your asymptote is that horizontal line, also known as the x-axis, or where y equals 0 be the name of that line. Okay? And then the last thing is your range. Range is just y is greater than 0, or you could say all positive real numbers. Okay? So fun. So fun. All right. Binomial theorem. Let's expand this rascal. Let me block these off here. And I'll just put some good old-fashioned parentheses. Bam, bam. All right. So f plus 3 to the 5th power. All right. Not too bad. Not too bad. Remember your rules. Binomial theorem. Let's use the binomial theorem. So the first thing I'm going to do is I'm going to use 5. Choose, actually, let me put it up higher so I can do more steps in there. So 5, choose 0, and it's going to be f to the 5th, and then it would be 3 to the 0, but I'm not going to write it. Plus 5, choose 1, f to the 4th now, counting down, and now the 3 start counting up, 3 to the 1st power. Okay, this is a pretty simple one. 5, choose 2, and this would be f to the third power, and 3 to the second power. Notice how the 5 choose 2. 2 is also the exponent of your second one. So, and then the 3 and the 2 always have to add up to the first number, that 5 there. So always adding up to 5. Let's keep it going. This is going to be 5 choose 3, f to the second power, and 3 to the third power, plus 5 choose 4, f to the first power, 3 to the fourth power, and only one more term remains here. This is 5 choose 5, and this is f to the 0 power, which I don't even write it here. We'll just do 3 to the fifth power, and we're good. Okay, now we just got to figure out what all these things are. If you remember your combinations, like how many ways can 0 things be arranged? How many ways can you pick no things? That's just 1. So this coefficient is automatically just 1. Out of 5 things, how many ways can you pick? Can you choose? None of them. So that's just 1. This is f to the fifth power. Leave it alone. Plus, now we're going to go 5 choose 1. So what's 5 choose 1? How many ways can you pick one thing out of 5 things? Right, there's only 5 ways you can do it. Now, you could plug this in the calculator. That would not be a bad option, bad choice there. So don't, feel free to do that if you want. You can also use the combination formula. So this would be 5 factorial over, in this case here, this is going to be 5 choose 2. So this is 2 factorial and 3 factorial. I should have done the other order, but you get the idea. It doesn't matter. They're all the same. So this is 5 times 4 times 3 factorial, and this is all over 3 factorial times 2. And the 3 factorials will cancel, bam, bam, and then the 2 and the 4 will cancel, leaving the 2, and so this is just 10. So I'm going to do f to the fourth times 3. Well, let me put them all together here. So I got this 3 to the first power, but I also have the 5 here in the front. Why not just multiply those now? So I'm going to do that. I'm just going to make this 15, right? The 3 here, and then the 5 choose 1, f to the fourth, plus, now this part turns into a 10, and 3 squared turns into a 9, so this would just be 90 f cubed. Okay, and we could keep going. 5 choose 3 is the same as 5 choose 2. This is 10. 3 to the third power is 27, so this is going to be plus 270 f squared. Okay, isn't this fun? And then we're going to do 5 choose 4 is the same as 5 choose 1. How many ways can you pick 4 things out of 5? That's the same as saying how many ways can you leave one out? And there are 5 ways you can leave one out, so this is only a 5 here. But this is 3 to the fourth power, which is what? 81? So this is 81, and 81 times 5 is what? 405. So do 405, and this would be f to the first power. And last but least is going to be, this is just going to be 1, and 3 to the fifth power is 243. So 243, and bam, there is your big polynomial. And that's it. Good stuff. That was fun. I mean, ish. All right, so here we go. Find an equation for the inverse of this one. You guys got to know the inverses, okay? How do you do inverse? Switch those. So this is going to be x equals 3 times y minus 16. And now we're going to add 16, because we're trying to solve for y. So x plus 16 equals 3y. Why not? And we'll divide by 3, and so you can just write y equals, and then do x over 3 plus 16 over 3 if you want that way, something like that. Okay, that's a nice little inverse function. All right, so that was fun. Let's go to the next one. It says identify the slope. Well, slope, we're just going to clean all this up real quick, solve it for y. I'd be real tempted here to just divide everything by 2. just make it a little bit simpler. So this is going to be negative x plus 2y equals 4. You didn't have to do that right the first step, but saving you work later. All right, now we're going to solve for y. Add x to both sides. So this is 2y equals x plus 4. Okay, now we'll divide everybody by 2. And this is going to be y equals 1/2 x, or x over 2, plus 2. Okay, and so the first question is, what is my slope? So you just make sure you answer the questions. Slope is 1/2. Awesome. What is my y-intercept? 2. So let's just plug it in, Y-intercept is 2. Slope is rise 1, run 2, rise 1, run 2, rise 1, run 2, and so on. And you just sketch a line through those points, and you're good. Okay, now. Okay. So fun. Moving on. Number 29. You gotta love these. These are absolute value inequalities things. And then the thing we struggle with sometimes is graphing these rascals, right? Graphing the solution. So let's go through and try this one. First things first, bend the parentheses. Once you isolate the absolute value, you notice how there's nothing else with the absolute value. It's just the absolute value, and then there's your sign. So if they had like +3 in there or something at the end of that, like is outside this absolute value signs, you'd want to move that first. But once you've isolated your absolute value, then now you can split it up into 2 cases. So case 1, what was in there was positive, okay? So we're going to bend the parentheses, right? Bend them into parentheses, right? And 2x plus 3 is greater than -1. Case 2. Case 2. This time we're going to also bend the parentheses. -2x plus 3 greater than -1. But in this case, we're going to instead throw a negative in front of those. Because what if what was in those absolute value was negative the whole time? So bend the parentheses, slap a negative on one, leave the other one positive. That way we've got our 2 cases and we're ready to roll. Okay, there's nothing in this. I'm going to focus on this one first. There's nothing in there that we need to settle out, so I can just go ahead and start working on it. -3, -3. And -1 minus 3 is -4. Okay, now there's a critical step here. You probably already see it. And when I divide or multiply both sides by a negative, I got to flip the sign. So bam, bam, this is x, and now this is just 2. So x is less than 2. Awesome sauce. Now, over here, let's do this one. Let's distribute the negative. So this is going to be 2x minus 3. Is that right? Yeah. And it's going to be less than -1. Now let's solve this. We're going to add 3 to both sides. And this gives us 2. And 2x is greater than 2. And we'll divide both sides by 2. And I get x is greater than 1. So x is greater than 1 but less than 2. You can always put that in one like statement like that. So you can just do like 1 is less than x is less than 2. In other words, x is somewhere between 1 and 2. And when you graph that, here's the key with graphing. You probably thought to yourself, how do I know what kind of graph to make? Well, there's only one variable, and because there's only one variable, you can draw a line like this, a single axis, okay? And this is where you put your x's and all that stuff on this line. So put 0 in there somewhere. So I'll put 0, and I'll put 1 and 2 and 3, whatever. I don't care. So now that I've got my stuff ready to plot, these tell you it's going to be open circle because it's not allowed to equal that. So we can put an open circle over this. You can put it on top of it or like right above it if you want. And I'll put an open circle at 1, and then I'll just shade in between there. Okay. This is not expertly done, by the way. This is pretty rough looking, actually. If I was doing it, I'd be I'd be tempted to just go like this, open circle, and connect the lines. But whatever floats your boat. We're good enough. All right. Solve by substitution. Gotta love some substitution. Substitution, if you're going to use substitution, normally when they tell you this, they're probably not going to say you have to do it a certain way, or if they do, you can be rebellious and pick a different way. But I'm going to do it by substitution because that's what it asks for. Elimination wouldn't be bad here. Even matrices, since it's kind of set up that way, you could do it that way. Just be careful because your x and y are different than they normally would be. But we're doing substitution, so there we go. Plus 2x plus 2x, and y equals 2x minus 24. Okay, now once you've isolated a variable, put a box around what it equals. Now find that variable in the other equation. Hey, there it is. And now all you do is plug this box into that box because that's what y equals. So now let's write it down. This is going to be 3. And then instead of y, I'm writing 2x minus 24, make sure you use parentheses, minus 5x equals negative 64. And sweet Christmas. Nailed it. All right. Now let's distribute and solve for x. This would be 6x minus, and this would be 72 minus 5x equals negative 64. There we go. All right, so now next step is going to be combining this. So this is just negative 5x. This is just x. So x and minus 72 equals negative 64. We'll add 72 to both sides. Oh, no. And x equals 64 and 72 is, can't do math today, it's 8. Yeah. So this is 8. There we go. Now, once you know x is 8, we're going to plug this 8 into the box that we made in the first place. So once you get the first thing, just plug it back into the box, and then it's easy as pie. Y equals 2 times 8 minus 24, which is positive 16 minus 24, which is just negative 8. So your answer is 8, negative 8. And I would recommend, in the midterm especially, to plug it in. It'd be so easy just to take these two values, okay? And I would plug it into your first one here, the one that you didn't use for the box. But you could do it in both, but at least do it in that one, just to make sure you're on the right track. And then you'll be good. So fun. All right, number 31. 31. Factor. Oh, this couldn't be easier. We're just going to take GCF of everything. Negative 8 would come out front. And so how many x's could you take? Looks like 5. So negative x to the 5th. Negative 8x to the 5th. And then just write what's left. So this would be 2x minus 1. And we're good there. I think the answer key had a different thing, but you could also throw another 4 out of there. So I think we're more right than the answer key. Woohoo! All right. On to 32. You can tell what a great job I did here. This one, I would recommend, if you have to graph something like this, just use Desmos or something, or use a table of values, plug it into Y1, and just go to your table, and then plot your points. And then just make your parabola from those points like that. There's not too much from that one that you need to worry about. Just get a few points and you're good. All right, something more fun would be 33. This is more like it. And again, these silly symbols here, I'm going to get rid of them for you. And we're dividing here. Remember, dividing is the same as multiplying by the reciprocal. So if I can multiply by the reciprocal, I'm going to be good. So when you go to divide, factor, 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 factor. I can't say it enough. Keep factoring. All right, so I'm going to factor the mess out of these, and I'm just going to rewrite it and make it this. So I can turn this into multiply if I turn this one into a fraction. Does that make sense? So by dividing by this is the same as multiplying by 1 over this. And so this is, I'm just going to make one giant fraction here. So this is going to be, factor out the x first. X times x plus 5. Boom. Okay, and that's it for the top. The 1, I don't need that. All right, and this is going to be x plus 3. Put parentheses around it. And now we're just going to factor as much as I can out of this. This is going to be 3x to the 5th would come out of there. And what's left when I'm done would be an x plus 5. Okay? And normally they set these up so they cancel something. And so x plus 5 and x plus 5 cancels. And then one of these x's cancels with one of these x's. So there were 5, now there are 4. Okay? And so now that's as far as we can go. So it's just going to be 1 over 3x to the 4th. I'm just going to put that first. And times x plus 3. Okay? Could you multiply that through? Technically, yes, but there's no point. Just leave it factored. It's usually easier to work with. Okay, and then if they wanted to know about restrictions of domains, the things that x is not allowed to be is any of this, and any of this. So anything except that top part, because that could be 0. But anything else that's dividing into something can't be 0. So then just set each of those factors equal to 0. So you could say x cannot equal, first of all, it can't equal 0 because of right here. So x can't equal 0. Can't equal -3 because of that over there. So -3. And then we crossed off that 5, but that was there to start with. So we still need to account for it. So can't be -5 either. Okay? If you're not sure, just set every factor in the denominator equal to 0. And those are what x is not allowed to be. All right, finding roots. Finding roots, another way to say find roots is find zeros. So this is 3x squared minus 8x minus 3 equals 0. And we're now going to try to factor first. So factoring is our first objective here. And then, we'll do what we can. Let's see if we can figure out what factors we've got here. So I would start, well, you could start with what would make 3x squared. A 3x and an x would make a nice 3x squared. Now, also in the back, you've got only 2 options as well. And if we're going to get anything close to 8, we're probably going to have the 3's be multiplied here. So I'll put 3 here and 1 here. The signs are different, but the middle is a negative, so I'll just do a negative and a positive there. Okay, so this takes some practice to get used to. It's not hard. You just have to kind of work it out. You could also do factor by grouping or something like that if you wanted to. But I think this is a pretty simple one just to guess and check. Okay, and if you're not sure, just go ahead and FOIL those 2 things, FOIL. And I know the first and the last will work because that's how I picked them, but check the outer and the inner. So outer and inner, I call it the OI check. So 3 times -3, that's -9x. And 1 times x is x. And if I add those together, it gives me -8x, which is my middle term. So I definitely factored it right. Okay, so these equal 0. So the first step, get 0 on the side, factor it, set each factor equal to 0. So one of these things equals 0. We don't know which one. Could be both. So I'm just going to write this out. This is going to be plus -1 minus 1. So 1 equals 3x. Divide by 3. And x equals 1/3. Oh, this is a fine answer. There's one root. The other root, we're going to add 3. And x equals 3. So it looks like 1/3. Oops, I think I missed the negative. Hold on. -1/3 because I subtracted 1. -1/3, there we go. And a +3, and that looks right. Okay. All right, this is classic. You want to find any values for which the following expression is undefined. It is undefined when the denominator equals 0. So how do we know when the denominator equals 0? We set the denominator equal to 0. When does that denominator equal 0? Let's do some factoring and find out. Okay, I'm going to try some old school factoring first. Okay. I think that's going to be better because there's only a couple options here and a couple options here. And when there's only a couple options, you only have a couple things to guess. So this is 5x and x. That's what I would do. And then 14, I'm going to lean towards, yeah, because of 37, I'm going to lean towards putting 7 here because when I do my outer, 5 times 7 is 35, and we're only a couple away, and that couple will come from right here, 7 times 2. 7 times 2 is 14, so the 2 times x would give us that. So this looks like I've got the numbers in the right place. Oops. And now I just need to do the signs. So the signs, let's see. It's a positive 14, so the signs are the same, and so they're both negative, okay? I know these are some Algebra 1 tricks. Hopefully you know how to do these. There are 1,000 resources online for just practicing your factoring. So if you need some practice, let me know. I'll hook you up on Khan or something else. There's tons of options out there. But yeah, if you need to practice your factoring, please do, because you'll be glad you did. It'll make your life a lot easier. All right. Anyway, so let's solve these two things. Let's do x minus 7 equals 0, or 5x minus 2 equals 0. We'll add 2, and 5x equals 2. We'll divide by 5, and x equals 2/5. There's one of our x, and I should say it this way. I should say x cannot equal 2/5, because, right, we don't want it to be 2/5. And the other one is going to be adding 7, and so x equals 7, but really x cannot equal 7. Okay, so these are the two no-go values on that one. Okay, good stuff. Now, would I take off if you put x equals instead of not equals? No, you're fine. Determine whether the probability experiment is binomial. So here's how you know things are binomial. There are clear, like, outlined success and failures, right? You can't have like red, green, and blue as being your outcomes. You have to have two. That's why binomial, that's why they call it binomial. There are only two outcomes, success and failure. In this case, we could define as getting heads as success, tails, fails. I don't know, however you want to do it. But that would be, yeah, that's binomial, so only two outcomes. The second part of that is there has to be a fixed number of trials. So I can't say flip the coin until I get 10 heads. No. That's not binomial anymore. You have to have a fixed number of trials from the outset, and so this case is fixed number of trials. All the probabilities for each trial is the same, so they're all kind of independent of each other. And yeah, this is a great example of binomial experiment. All right, find an equation for the inverse of this rascal. Looks familiar. Kind of like the other one. X equals 3/4 y plus 11. So just switch those. And now just solve for y. So you can do a couple things here. You can actually, you probably wouldn't do this, but I'm going to do it just to show you that you can. Just to get rid of the denominator, the fraction here, I'm going to multiply everything by 4. So this one by 4, this one by 4, and whatever. So this is now 3y plus 44 equals 4x. I don't know that I saved any time on that because I'm going to end up with a fraction anyway, but alas, here we are. Minus 44 minus 44, and I get 4x minus 44 equals 3y. And now we just divide everything by 3. Whoop, 3, and I get 4/3 x minus really 44/3 equals y. Nice inverse. All right. Synthetic division. You got to love synthetic division. So first thing you want to do is figure out what you're dividing, what number, what's your magic number. So what I do is I set this equal to 0 first, right? And then I would add 3. So x is 3. That is the number I'm putting in there when x is 3. So when you get your L ready to draw here, so there's your L. 3 is the magic number we're putting up top. Okay, now put all your other numbers in. Things to check for. Count down your x's. So 3, 2, 1, 0. Boom. This is looking good. Now put your coefficients in. 2, 5, -5, 4. And once you get this set up, it is so stinking easy. Okay? Drop a 2. Not going to go there. All right, 3 times 2 is 6. Now add those up. That's 11. 3 times 11 is 33. Okay? Now add those up. 33 and -5 is 28. Right? And then the next one is 3 times 84. Yeah? All right, 3 times 28 is 84. And then we'll add those up. That's 88. So how do you rewrite this after synthetic? You could do 2x. Now, what would it be? Squared, cubed, whatever. How do you know? And one is that you divide it, so you're going to start with the next one down, or just work backwards. This must be your constant. This is your x term. This is x squared term. So it's going to be 2x squared plus 11x plus 28 plus 88 over, and then whatever you divide it by, x minus 3, like that. Okay? If you wrote remainder 88, that's also totally cool. All right. Composite functions where you stuff one function into the other. I'm going to take this entire thing that is g of x, and it's telling me to let's put a g of x inside an f of x. It's like a turducken. I don't know, you know what that is? So I'm going to put this inside where x was, and we'll be good. So this is going to be 5, and then x plus 4 squared. Okay, so this whole thing gets stuffed into where x was in the other one. So minus 7. So here's my g of x inside where the x was here, and I just rewrote it here. This is f of g of x. Okay, composition of functions. Okay, I could also say it's FOG, fog. All right, and x plus 4 squared. I guess I could work that out a little bit if I wanted to. Why not? This would be 5 times. So this is x squared plus 8x, right? Plus 16 minus 7. And if you work this out, this is 5x squared plus 40x, and then see 5 times 16, and then take away 7, so it'll be 80 minus 7, 73. Okay. If you stopped here, you wouldn't be wrong, but you'd probably want to clean that up a little bit. Okay. All right. Oh, it's the last one. Okay. This is technically an objective function type problem. And I'll just talk you through it because I've already done this one somewhere. Let's see. A baker's making pastries. All right. There's the price of the one, whatever. We're looking to keep cost to a minimum. This means you're going to find an objective function, and you're going to use the minimum to make it happen. So to keep cost to a minimum, you're going to, let's see, you're going to create your cost function over here. So cost function, and always start by defining your variables. So my variables, x can be the number of large, y could be the number of small. Easy enough, right? So the x is the number large, or the other way around, whatever you pick. All right, now what does he say? The baker will make 180 pastries. In other words, x plus y put together has to equal 180. Okay, so start by that, and then because the cost is 230 per large and 130 per small, you can make your cost function over there. All right, now 4x equals y. Where does that come from? That's right here. 4 times as many people buy small pastries as large pastries. In other words, 4 times the large number would equal the small number, the small pastry number. All right, so there's my 2 constraint functions. And I'm going to graph these 2 constraints. So let's graph those rascals. And these are actually, you'll notice that these are not inequalities. You're not going to have like a side of the line shaded. It's just going to be a straight line. And we're just going to see where those lines cross, and then we'll be good. So let's pull up Desmos. All right. So we had that x and I can remember 180. So x and y, x plus y is equal to 180. Okay. And what was the other one? 4x equals y? Yeah. So 4x equals y. All right, awesome. Now let's see what kind of graph. Oh, if I zoom all the way out here. So all my solutions are on both lines. Well, that means there's only one actual solution on this thing. It's this point right here. If you double tap it on Desmos, it'll let you know what that value is. It's 36 is the x value, 144 is the y value. 36 equals x, 144 equals y. And remember, I go back up here to see how I define the variables. Y was my smalls, x was my larges, and so there I need 36 large and 144 small. Now, if you did your x and y differently, it's going to just look like 144 and 36. But however you define your variables, let that determine what your x and y are at the end. Okay, that is it. That's all she wrote, guys. You're going to do fantastic. Take a look at all the resources I gave you. Study, work hard at it. You're going to do fine. Don't be nervous. Be a little nervous. Nervous enough to study and put some work in, but y'all do great. So appreciate you, and keep up the hard work, guys.